Hello there, today we're talking about completing the square. It's a method we use to factorise some expressions and in fact solve some quadratic trinomials, as we'll see later in the course. So completing the square involves two steps. First step is to form a perfect square out of the first two terms of a quadratic trinomial, and the second step involves factorising the resultant difference of two squares. So let's have a look at our first example. Okay, the general procedure is this. We're going to rewrite the first two terms, x squared minus 4x. Then we are going to halve the coefficient of the middle term right there and square it. We're going to halve it and square it. And we always start by adding that. So we're going to plus, now half of negative 4 is negative 2, and we are going to square it. And of course, what we add, we must subtract to preserve the equality of the expression. So minus negative 2 all squared, and we bring down the negative 2 from right there. Okay, so now what we can do is form a perfect square over this part of the expression, a perfect square, and it's very easy to do. We go like this, equals x minus 2 all squared minus, and we've got to be careful here, anything squared is positive, so it's minus a negative 2 squared, so it's minus 4 and then minus 2. Okay, so just tidying that up a touch, we've got x minus 2 all squared minus 6. And what we have here is a difference of 1, 2 squares. That's definitely a square, it's x minus 2 all squared, and 6 of course is not a square number, but we can treat it as a square number when we consider that its square root is just the square root of 6. And the difference of two squares, of course, is relying on the fact that if we've got a squared minus b squared, where a and b can be any expression, that can be factorised to a minus b bracket a plus b. So we're making use of that here. Alright, so now in this case, of course, a is going to be x minus 2 and b is not going to be 6 but the square root of 6. B squared is 6. Okay, so putting that together, what we get is this: x minus 2 minus the square root of 6, sorry about the change of colour, and x minus 2 plus the square root of 6. And that's the end of the story. There's nothing else we can do to that expression to make it better. That's in fully factored form. Here's our second example, which doesn't look terribly complicated. So what we do is we say that's equal to x squared minus 6x, so we just write down the first two terms. Then we add some terms so we can form a perfect square. Now remember, it's half the coefficient of the middle term. So half of negative 6, remembering the sign belongs to the term on its right, half of negative 6 is of course negative 3. So we're going to add negative 3 all squared, and what we add we must take away. Like so, and minus 10 at the end. Okay, so what we can do is now form a perfect square out of this part of the expression, and it's really easy to do. We say it's x minus 3, notice where the minus 3 comes from, all squared, and then we've got minus, now negative 3 squared is positive 9 minus 10. And what we have from there is x minus 3 all squared minus 19. And now we have a difference of two squares, difference of 1, 2 squares, where a is x minus 3 and b is the square root of 19. And so we can simply write our answer as x minus 3 minus the square root of 19, and then x minus 3 plus the square root of 19. So that one's done. Now this one's just a little more complicated because we're going to end up dealing with squaring some fractions. X squared minus 3x minus 5. But do remember that the principle is exactly the same, and we're not going to change the rules for anything. So we begin by adding half the coefficient of the middle term and squaring it. So plus, now it is -3, we halve it by dividing by 2 like that and square it. And what we add, we must subtract, like so, and then we subtract the 5 at the end. Alright, so now we can form our perfect square. It goes like this: x minus 3 on 2 all squared. And now we're addressing this part here, so we've got to be careful a bit. So we're going to subtract -3 all squared is 9 on 4. So to square a fraction, you simply square the top, square the bottom, square the numerator, square the denominator, and any number squared is positive there. Okay, so, and then we subtract 5. Alright, now I'm just going to rewrite the right hand side of our expression because it's a bit cumbersome at the moment. And I want to treat 5 in terms of quarters. So to do that, I simply times 5 by 4 to get 20 and write it over 4. And you can see that -20 on 4 is indeed -5, I hope. So tidying that up a bit, we get x minus 3 on 2 all squared minus 29 on 4. And what we have now is x minus 3 on 2 minus, okay, so now we're factorising the difference of two squares, so minus the square root of 29 on 4, open up brackets, x minus 3 on 2 plus the square root of 29 on 4. Now the only thing I might want to do there, in fact should do really, is deal with this square root of 29 on 4, because you will remember, I hope, the laws of surds tell us that this can be rewritten as a square root of 29 over the square root of 4, but we know the square root of 4 is just 2. So just tidying it up a touch, we would say this is equal to x minus 3 on 2 minus the square root of 29 on 2, close brackets, x minus 3 on 2 plus the square root of 29 on 2, close brackets, and that's that example done. One final example to show you that we can use the completing the square method when the coefficient of x squared is not 1. Now we could use PSN on this, but we haven't covered that in class, so we'll use the completing the square method. So what I do is I take out the 2, like so, and I'm going to divide each term by 2. So we end up with x squared plus x on 2 minus 3 on 2. And I hope you can see that the second line is exactly the same in value as the first line. Okay, so now we can complete the square on what's in brackets. Let's do that. It's a bit messier, but we can do it, and we must. So we've got x squared plus x on 2. Now the coefficient of x here is a half. I hope you can see that. X divided by 2 is the same as a half times x, isn't it? So the coefficient of x here would be a half. And what we've always done is half the coefficient and square it. So a half of a half is a quarter, isn't it? And so we're going to add that and square it, or add the square of that, I should say, to be more accurate. So plus a quarter, half of a half is a quarter, and square it. And what we add, we must subtract. And we bring down the minus 3 on 2. Close it off with a square bracket. Alright, so now we can form our perfect square on this part. And it's very easy, isn't it? So we go 2, we're going to need square brackets still, x plus a quarter, all squared, minus a 16th. Remember, to square a fraction, we simply square the top, the numerator, and square the bottom. So squaring 1, we get 1, Squaring 4, we get 16. And we're going to minus 3 on 2. But instead of minus 3 on 2, what I want to do is treat this as 16ths, because it's going to be easier to manipulate later. So I can do that. I can convert halves to 16ths by timesing that by 8, can't I? 2 times 8 is 16. And what I do to the bottom, I must do to the top. So that's going to be minus 3 times 8 is negative 24. So minus 24 on 16, like so. And what have we got? Okay, so just tidying it up a touch, we've got 2. We're going to need our square brackets. We're not doing much in the early stages of this line. Squared minus, okay, so we've got minus 1/16 minus another 24/16, so that's minus 25 on 16. Okay, so now we're ready to deal with our expression as a difference of 1, 2 squares. So a squared is x plus a quarter all squared, and b squared is 25 on 16. We want a, so it's x plus 4, and we want b. Now the thing about b is that it's a square root of b squared, so we take the square root of 25 and put it over the square root of 16. So I hope you recall your rules of surds, because that's going to come in handy. So we've got 2, and what we can do in fact is get rid of our square brackets. So plus a quarter minus the square root of 25 is 5, square root of 16 is 4, open up bracket, x plus a quarter, and then it's plus 5 on 4, like so. And that can be simplified quite a bit. So we'll do that right now. What can be simplified is this bit here. So we've got 1 quarter minus 5 quarters. So that's going to come to a nice even minus 1, isn't it? Negative 1. So let's do that. Equals 2x minus 1. And then in the other pair of brackets we've got x. We've got 1 quarter plus 5 quarters, which is going to give us 6 quarters. Now instead of writing plus 6 over 4, I'm going to simplify the fraction and put plus 3 over 2. And boys, that's how we can factorise a non-monic quadratic trinomial by using the completing the square method. Goodbye for now.